Hey fam, welcome to Driven Life. Hey fam, welcome to Driven Math and Physics. So today we're going to be looking at another problem on Archimedes principle. And so this problem says a cube of side 5 centimeters and mass 1.2 kgs is suspended in a liquid of unknown density. It floats with 75% of its volume submerged. So keyword, it floats. So 75% of its volume. The first question, find the volume of the cube. So it will be volume of the cube will be the length squared or side raised to the power 3. So that will be equal to 5 centimeters to the power 3, or 5 times 10 to the power negative 2 to the power 3. What you end up getting is times 10 to the power negative 2 there. This is raised to the power 3. What you end up getting is 0.000125 cubic meters. Okay, that's our volume of the cube. We're done with part A. Part B is density of the liquid. To find the density of the liquid, people, we need to really use the law of flotation. The law of flotation says weight of the cube, for it to float, it should be equal to weight of the liquid displaced. Okay, now the weight of the cube will be density of the cube multiplied by, maybe let me just do it step by step for you to understand. Weight of the cube will be mass of the cube times gravitational field strength, which is equal to weight of the liquid displaced is density of the liquid times volume of liquid displaced times gravitational field strength. So these ones can cancel because they're on the same side. Same thing on different sides of the equal sign. So it will be mass of the cube is equal to density of the liquid times volume of liquid displaced. From there, this mass is also density of the cube times volume of the cube, which will be equal to density of the liquid times volume of liquid displaced. Can you see that? Okay, so they want us to find density of the liquid, which is this parameter right here. Now, to actually get there, we need to remember that 75% of its volume is what? Submerged. So we know the volume of the cube. We know the it means the volume of the liquid displaced. Remember, volume of liquid displaced is equal to volume of the cube submerged. Okay, so it means the volume of the cube submerged is 75% of this. Can you see that? Okay, so it means the volume of the liquid displaced, it will be like this. Density of the cube times volume of the cube is equal to density of the liquid, that's what we want to find, multiplied by 0.75 volume of the cube. Can you see it? This is what is equal to volume of liquid displaced. All right, let's make density of the liquid subject of formula. That will be density of liquid is equal to density of cube times volume of cube divided by 0.75 volume of cube. Okay, so this and that can cancel. You get density of cube divided by 0.75. What ends up happening is we end up getting density of the cube. Do we know the density of the cube? Let me just see. Okay, we can actually find it. So it will be the mass of the cube divided by volume of the cube divided by 0.75, which will be equal to mass of the cube is actually given here is 1.2 kgs. Okay, 1.2 kgs divided by 0.000125 cubic meters. This divided by 0.75. Okay, so if you calculate everything, you end up getting 1.2 kgs divided by 0.000125 cubic meters times 1 over 0.75. So the answer you end up getting is 1.25 kg. No, actually, let's just do the final answer, which is 12,800 kgs per cubic meter. This is density of the liquid. Okay. Now, the question that we have here is that would the cube float higher or lower in water? So water, if you look at this liquid, it has a density of 12,000, and water has a density of 1,000. So this 12,000, you find that the cube is 75%. The cylinder is 75%. I think, let me see if the cylinder is a cube. The cube is 75% submerged. So what if you put it in water, which is literally 10 times less in density? This cube would actually completely sink. Completely. It will disappear. Okay? The density is too low. Okay? But anyways, thank you so much for tuning in. Tell me how you could have done it differently. Otherwise, thank you for watching.